بسم الله الرحمن الرحيم. السلام عليكم جميعا وحياكم الله. Inshallah, today we will present our final presentation, and for who attended before our presentations, this presentation gonna be different because this one is an all-in-one presentation. We will take you through the project from its beginning to the end of it. Okay. So as you know, Kuwait is located in a hard geographic location that causes a lot of troubles to us. And one of these troubles is the desert. The desert is a source of a very fine sands that can be moved by the winds. And when the sands move by the winds, it will start to accumulate on roads, causing many problems like car accidents, logistic obstruction, and it impedes the movement of the residents of new cities. Okay. Logistic obstructions means that we have an international trucks that moves the goods from the neighboring countries, and the last one is that Kuwait is becoming the Kuwait cities are becoming larger. We have new cities like Sabah Al Ahmed City, Al Mutla' City. And all people who are living in these cities are suffering from the sands accumulations on road. So here is a map that includes all critical roads that are affected by the sand accumulations. The first road is the Asalmi motorway. Trucks uses this way to move the goods from Saudi, Jordan, and Syria. The second road is Safq Road. This road is very important because it serves Sabah Al Ahmed City and the residents of the city. And the last road is the As-Sabbiya motorway. This road, inshallah, will serve in the future Mina Mbarak Al-Kabir, in the future, Mina Mbarak Al-Kabir port. And this road problem needs to be solved. So the current solution is that the government have contractors that uses loaders and road sweepers to remove the sands from the road. As you can see in this video, at the very beginning, the loaders come and remove the mountains of sand and put it on the side road, and then the road sweepers come and remove the remaining 1 centimeter or 2 centimeter of the sand, because the loaders are not capable to touch the asphalt, otherwise it will break it. So there are many disadvantages of the current solution. It will double the effort. You need both loaders and road sweepers to do one operation. Also, you will double the need of the laborers. The second thing is that it is money and time consuming. You need more than 2 days to complete one road. Also, it costs us hundreds of thousands of dinars. The last thing is that, as you know, Kuwait is full of unutilized potentials. Okay, and we can utilize these potentials more. Okay, we have a Ministry of Public Work engineers. We consider them as a manpower. Also, Ministry of Public Work have many vehicles of Pajeros, thousands of them. So we can take benefit of them. So there are many other possible solutions. The best solution is that we need to plant the desert. Okay, it is permanent. It will stop the global warming. However, it needs a huge plans at the government level, and we are not capable to do as students. The second solution is that we can design a robot which will reduce the manpower. It is fully automated. However, it is complex and needs to be recharged. The last one, we can use the snowplow that exists in the northern countries. It is time and money efficient. It utilizes the unused resources. However, it is not permanent. You have to keep doing the process continuously. Not like the planting, it will solve the problem from spaces. So when comparing all possible solutions, we will choose the snow plow and modify it to be capable to push sands from the roads. And this is our mission statement. We will design a car attachment with a road sweeping and bulldozing capabilities that is specialized for moving the accumulated very fine sand on the road. So we generated many concepts for this sand plow, and my colleague Abdulaziz Fawzan will continue it.
Thank you, Musab. Now, before starting with the concept generation, what we want to know what exactly our primary consumer, the Ministry of Public Works, wants. So what we did was we had an interview with one of the engineers, and he gave us some customer statements. From there, we translated them into interpreted needs and used those needs to find metrics that specify these needs. After that, we made a needs metrics matrix to further understand their requirements. From there, we categorized each of the functionalities of that project in mind and divide them into each of their functionalities. For instance, their sand removing mechanism, using a plow or using brushes, and for example, a trip mechanism that tries to avoid obstacles or obstructions in the road. Now, we started with the concept generation. What we wanted was to look at several chunks and functionalities, such as the attachment method. We looked at front receiver hitches and hook attachments. From there, we looked at also the lifting mechanism, which gave us 5 options, which are the electric winch, manual winch, the power screw, the hydraulic, and finally, manually lifting the mechanism. For the thin layer removal, we only had two options, which are the brushes that you can see everywhere in street sweepers, or blowers. After that, we wanted to know how to use these brushes or blowers using motors, such as the DC motor or AC motor. And for the brush lifting mechanism, similar to the lifting mechanism of the plow, we looked at electric power screws, normal manual power screws, attaching the brushes to the main lifting mechanism, and finally, manually removing and attaching. The final chunk was the trip mechanism. We only had 2 options, which are the trip only trips the bottom of the plow, as you can see here, or the whole plow. After we found and looked at several options, we generated the first concept, which looks for the automation of the product. The second would be to try and make it as manual as possible. The third would be to make it as strong as possible and durable for high forces. The third would try to minimize cost. And finally, the fifth would be for simple manufacturing. Now, for the concept selection, the process that we went through was after we made the generated concepts, they go through a screening, and from that screening, we wanted to filter them out. After the concepts were filtered, they went through another screening called the concept scoring, which is a bit more in-depth and decisive. It uses weighted scoring to better find the best concept. From there, we would find the final concept. Now, for the concept screening, we take the selection criteria from that interview that we mentioned before and compare each of the concepts with a reference. Our reference was the snowplow, since it's the closest one to our product. From there, we look at the net scores and rank them and determine whether or not we want to continue or not. Now we finished with the screening and decided whether or not to continue. We went to the concept scoring, which similarly looks at the selection criteria and compares concepts. However, the difference, as I mentioned before, was the weighted scoring. From there, we look at the weighted scores and similarly to the screening, look at the total scores and decide whether or not to develop and or discard the concept. We decided to go with the final concept, concept E, which looks for simple manufacturing, since manufacturing was a key point and very important to us, since not a lot of workshops would like to work with heavy-duty prototypes. For the attachment, we chose to go with the hook attachments, since designing a new front hitch would be timely and costly, and similarly, 2 points for the attachment instead of 1, making it more durable. For the lifting mechanism, we decided to go with the manual winch because it's simple and effective, and and the brushes that were mentioned before just attached to the main lifting mechanism. Finally, for the trip mechanism, we decided we had only two options, and we decided to go with the bottom trip. This was chosen mainly due to manufacturing issues and due to the fact that using the whole plow would further decrease the strength of the plow. Excuse me. And for the final chunk would be the thin layer removal, which we chose the AC motor with an inverter solely due to the fact that DC motors are not readily available in the market. The ideal case would be a DC motor, because using a DC motor would be using less components, since a power inverter is needed for an AC motor. Now I leave the rest to my colleague Abdul Wahab discussing the detailed design. Thank you.
Thank you, Abdulaziz. So after we designed our product in system level, the next step was to design it with more details, like getting parameters like dimensions, stresses, factors of safety. So before we start the analysis, we had to determine the forces that are exerted on the system. Our system is simply a car, a snowplow, and a block of sand. And there is a friction between the road and the block of sand. As the car moves forward, the sand exerts friction force towards the plow, and there is a reaction between the car and the plow. And the friction force is simply this equation. So after we determined the forces, we were ready to start the stress analysis. So we started with an arbitrary design. The aim of this design was to ensure the feasibility of the project and to determine the points of maximum stresses. So two loads were applied. The first was the gravity load, the weight of the system. The second was the pressure from pushing the sand. The maximum stress locations were the hinges in the front and the mounting hitch. So this design was very over-designed. It is strong enough to sustain a load of approximately 2 small cars. So we have to improve it further to optimize it. So we use the standard sizes, smaller sizes as well. We added the cylindrical rod in order to help the plow rotate up and down. And the plow hinges were removed since we didn't need them, and they were stress concentration points. The assumptions for this analysis are that the support is rigid, because we only wanted to study the frame and design the support later. No tires support the frame, because this is the worst case scenario, and it is always better to design for worst case. The third assumption is that the material used is AISI 1020. So we applied the loads mentioned previously, and the maximum stress locations were these points here. The steel size we used is 5 millimeter thickness. We got a factor of safety of 1.9, and the mass of the system is 110 kilograms. The factor of safety was good for us, but the mass was very heavy. We wanted to reduce the weight even further. So we added a third bar in order to allow us to reduce the thickness, because this is the place where maximum stress is. So after we added this bar, we managed to reduce the thickness to 3 millimeters. The factor of safety increased to 3.8, and the mass decreased to 73 kilograms, which is a very good improvement with respect to the previous design. And regarding the car mounting, we designed this piece. It is attached to the car by 2 bolts here. They are tied to the car chassis. And the frame will be held by this hollow square shape. And a pin is attached here to fix the motion of this frame, because without the pin, it could go right or left. So this pin will help it stay in its place. For the stress analysis, we had fixed boundary conditions in the bolt's place, and we had load in 2 directions. The first the downward load for the weight of the system. The second is the horizontal load for the pressure of the sand. So this piece is the most critical part of our product. If it fails, the whole system fails. So we intentionally over-designed it because we don't want it to fail. And if we increase its mass, it wouldn't be a problem because this is a very small piece compared to the rest of the frame. And the realized factor of safety was 9.2. After we designed the system in detail, the next step was to manufacture the prototype. And my colleague Abdulaziz will continue with that.
Thank you. Now, for the manufacturing, we wanted to look at visually how the product would look. So we tried to draw it in AutoCAD and look at how exactly we wanted the manufacturable design to be. And this is another view, an exploded view of the design. Now, for each of the components, we used SI 1020 steel, hollow square bars, a solid cylinder, radius of 1.5 centimeters, and finally sheet metal that's a thickness of 3 millimeters. For the manufacturing process, what we wanted was to first look at the design that we had and split the process into 4 sub-assemblies. We had the ready-made items, the frame, the plow, and finally the car joint. After we assemble all of these 4 components, we finally assemble the completed prototype. Now, I'll be explaining each of the sub-assemblies and showing the completed designs. For the ready-made items, we only had 4 ready-made items that were found in stores. The manual winch, the AC motor, the tire, and the street brush. For the manual winch, we obtained them in Jawad al-Saffar. For the motors, Al-Qamar. For the tires, Jawad al-Saffar as well. And finally, the street brushes were found in Ma'rafi Cleaning. For the frame, or specifically the chassis, we wanted this design. And for manufacturing, there's only 2 basic components that we looked at. It's welding and drilling. We only needed to weld the beams and drill holes to allow the cylinder to pass. And the final sub-assembly looked like this. For the motor cage, we had an issue with the brushes. They were too short and wouldn't reach the ground. So what we did was we tried to lower the mounting position to make it closer to the ground. And what we were left with is the final sub-assembly being as follows. For the plow, it's simply just a sheet metal that's been bended, and a bending machine was used, and the final sub-assembly was as follows. Now, for the car joint, we had an issue. What we wanted was a thickness of 5 centimeters. And the problem was the standard dimensions did not provide 5 centimeters. So we had this issue of not being able to manufacture this sub-assembly. However, as my colleague just mentioned, the car joint was over-designed. So what we did was basically, instead of using 5 centimeters, we used 2 centimeter thick components and just welded them together and used that instead of 5 centimeters. And the final sub-assembly looked like this. Now we finished all the sub-assemblies. All that's left is just assembling it. This was the AutoCAD design that we wanted, and this was what we got when we manufactured it. Now, after we finished manufacturing comes the feasibility. And this is what my colleague is going to discuss. Thank you.
Okay, so during the design process, we have been gathering information, and after we finished the prototype, we did a feasibility study to evaluate the project potential to success. So we studied 3 areas of the project feasibility: the technical, the economical, and the operational feasibility. And under each area, there was some questions that we had to answer, like, do we have the project requirements? Will the project make profit? Is the project actually reliable? So starting with the technical feasibility, what makes the project technically possible? We need the tools and the equipment required to manufacture each unit, and we need the skilled labor that knows how to use these tools, and we need the components of each unit. As my friend Abdulaziz illustrated, we do have the tools and equipment in Kuwait with enough capacity for mass production, and we do have the skilled labor with the blueprint on how to assemble each unit. But when you come to the components, yes, we did buy the components from local stores in Kuwait, but when we talk about mass production, we had to search for suppliers, which we did, and simply by that, project is technically possible. For the economic feasibility, the question is the project profitable or is the project affordable? So these are the total costs of the project, starting with the materials, which are these. These are the total costs of the actual prototype. And these are, if we want to get the exact same components with the exact same specifications from the Chinese suppliers, you can see the difference. And the manufacturing costed a total of 490 KD. So the total costs per unit are 580 KD. And we decided that we're going to sell each sand sweeper for 775 KD. Before you judge us, keep in mind that loaders cost the country 2,400 KD per day. So we did the break-even analysis, and as you can see here, we're going to make profit out of this project if we sell 25 units, 25 sand sweepers. And this number 25 takes us to the next point of the potential market. Like, where are we going to sell 25 units? Obviously, we do not need 25 sand sweepers in Kuwait. So this is a map showing the countries with actual reported cases of sand accumulation, where they used loaders to solve the problem. So we have the North Africa region and Mauritania. And after we did research, we found that the governments there, unfortunately, they do not care about this problem until it reaches a severe level where they need loaders to solve it. On the other hand, we have the GCC region, where, as we mentioned earlier in the introduction, the governments here actually do care about this problem, and they spend hundreds of thousands every year on solving it. And also on the individual level, the people have high incomes, so they can afford an 800 KD product. So the JCC is our potential market. Finally, for the operational feasibility, when we try to sell a product, how do we convince people? We show them, is the product actually reliable? Is it usable? So can the sand sweeper actually sand sweep? Showtime. Thank you.
So, if anyone have a question, you are very welcome.
Anybody has a question? Even from the audience, feel free to ask any question. If something wasn't clear or you wanted more clarification, you can ask a question.
I would like to congratulate you for this nice piece of work.
Much appreciated.
And also to congratulate Professor Savi and Jean Habib. I have two questions, very simple one. First one, what's the environmental impact of your project?
Actually, There is no environmental impact since those Pajeros, Ministry of Public Work Pajeros, are already driven every day. So we are just utilizing these Pajeros يعني, when they are used. So there is no environmental impact. However, maybe the brushes, there is like debris from the brushes if they are not good. So this could be an environmental impact. Yes.
And then the sand that you're pushing, where's it going?
It is going to the road shoulder.
Shoulders.
Yes, road shoulders. Yes. As you increase the angle of the plow, the efficiency of sliding will become higher and higher.
And you're doing it manually. It's not
No, it is fixed.
fixed.
It is fixed. Yes. But if you want to make it very long, you can make it 80 degree and enjoy the trip.
At the picture you started with, you have it? The
Again?
picture you start the project with, can you put it?
Okay.
No, not this one. The first one, the screen.
This one?
لا أول شيء
بالintroduction؟
المقدمة أول شيء.
Are you talking about this one?
لا الصورة اللي صورة فوتوغرافية بالبداية كنتوا حاطينها قبل أن أدي.
أول سلايد مال introduction.
So environmentally, is it better than loaders or what?
Yes. Loaders uses diesels, and the diesel is very has a huge impact on the environment.
Okay, so
What I see, I'm sorry.
Yes.
It's your angle is going one way. Could be the other side.
No, we are planning to bring two cars like this.
Which
Two
means,
cars.
I mean,
And the car on the left will throw the sand to the car on the right. يعني, it is usually happen like this.
Which means at the time you're gonna remove the sands, no other cars are moving. You're gonna block the road, right?
Yes, it is always the road will be always blocked.
Blocked?
Yes, even with the loaders.
No, because I mean, when there's snow in the, let's say, European countries, you see it's moving while it's still using the road. Nothing is gonna obstacle you.
Yes, it is moving, but the cars
Like,
beneath it.
you see?
Yes. There is
Yes, like this one.
a
So
technique used.
لا مو هاي الصورة اللي بيها اللي بديتوا فيها ملونة اللي كان فيها شارع وعليه تراب.
ارجع صورة الإمارات. هذا سايد.
هذه. And هذا one way or two ways.
هذا two ways هذا.
Okay, let's say we are in the right way. I mean, going to the city.
Okay.
You're gonna start from which position? The first line, the right line, left line. I mean, you're gonna accumulate them at one way, so that nobody's gonna go through this road.
Yes, you can do them. The two of them at the same time. There is a technique used for snowplows. We have a video for it. Please, the two sides at the same time.
عبد العزيز لو ترفع صوت عبد الوهاب ترفع صوتك شوي.
As you can see. They are using multiple plows at the same time.
طق space.
They are using multiple plows.
معليش اسمع افهم انا اشرح اكسب وقت.
It's better to see the video. They are using multiple plows at the same time. So one plow throws the snow to the other one until the last one to the right pushes the snow to the road shoulder.
So
they are working in
you're
parallel.
expecting to have the same behavior.
Yes, we can use multiple plows, using them together, and the same effect will happen.
Okay. Now those cars also do have this in one direction, or it's movable.
It depends on the product.
You weren't able to do it as a moving position.
We were able, but we didn't think that will be very beneficial.
Okay.
خلي المايك عندك قرب.
Okay. Thank you. Mansi.
Other questions? The audience.
We have a question online. Dr. Alia, you want to ask your question?
I was trying to write. First of all, I see a very well organized presentation for the students.
Thank you.
They work in a great harmony, and the transition from one person to the other person was so smooth and nice. So, just a quick question: did you operate your time tweeter for a long period of time, or just like a few minutes as we saw in the video? And what, as Dr. Majid asked, what was the height of the plant? What was the maximum height that you can cover?
Regarding the maximum height is 0.5 meter. Regarding the maximum height, and regarding the first question,
Yes, maybe I didn't understand the question.
How long did you run it for?
The same duration as in the video.
So, in the operation, you might need to operate it for hours. So, don't you think your system might fail at a certain point? You should run it for 1 or 2 minutes.
No, I don't think so. We did our analysis and we are very confident with it. Thank you.
All right. We have Dr. Fatma Mado also has a question. Please go ahead.
First of all, I would like to thank the students for their great work, very well put together presentation. I'm so proud of each one of the students. I had the chance to teach the students before in class.
thank you.
I have a few questions. I might miss some information covered in the presentation, so sorry in advance. You answered already, Dr. Aida, that the maximum height is half the meter of sand, but we know some sandstorms will accumulate sand higher than this. So how the system will help in such cases?
Actually, our goal is to remove only 0.5 meter, and this is our design decision. If the sand accumulates more than 0.5 meter, we will need to use the loaders.
Okay, then the next question. In the presentation, it seems that all the analysis of the factor of safety, or you name it FOS, in your presentation, seems to be done using static failure analysis. Am I right?
Yes, we are using static failure analysis, but again,
Which failure theory did you use for your safety?
von Mises stress.
Why did you choose for Mises? What's your
Because we think
decision was based on what?
it is the most used theory for steels, and that was enough to use this failure theory.
But as we all know, static failure, which is only comparing either the yield strength or only the stress or whatever, does not really give a good indication regarding fatigue failure. So we know that at some point you will have failure, but when you look at fatigue, your system is running under duration of hours or days if you accumulate the days of the year. So it's definitely fatigue loading.
Yes, it will be fatigue loaded, but we accounted for that by using a high factor of safety, and we think it is enough for accounting for fatigue and dynamic loading.
I beg to differ. Fatigue loading have really different analysis compared to static analysis. So static fatigue safety factor does not reflect your fatigue. If you check your endurance limit, you might be better. But only the safety factor, that's not an indicator. I wish that you look at least the endurance limit. But anyway, good work, and thank you so much for your presentation.
Thanks. Thank you very much.
Thank you very much. All right, thank you very much.